Hello, Algebra 2 students. This is the first video for section 3.6, theorems about roots of polynomial equations. Essential question is, how are the roots of a polynomial equation related to the coefficients and the degree of the polynomial? And we're going to use roots of a polynomial equation to find the other roots. We're going to be able to find roots for cubic, quartic, quintic functions. It's not going to matter. It may take a while, but we can find them. The rational root theorem, they wrote this first thing wrong. There's an error in here, so I'm going to skip down to the second paragraph. If the polynomial equation p of x equals 0 has any rational roots, then each rational root has to be in the form p over q, where p is a factor of the constant term. That'll be this one here. This is the constant term. And a subscript 0 is and q is the leading coefficient. This will make more sense with this next example. Basically, we need to find if there's going to be a rational root, it's going to be a real root. It's going to be any factor of this divided by any factor of this. So that's all we're going to look at, as long as you have it in the correct order, and as long as you have it equal to 0, right? It would have to be an equation in order for us to find the roots. In other words, we look at this number here, -8. What are the factors of -8? Well, it could be positive or -1, positive or -2. These are the factors of -8. Positive or -4, and positive or -8. Those are the possible factors of -8. And we're going to divide all those numbers by the factors of 5, which would be positive or -1, and positive or -5. This will make more sense with the next example because I'll go farther with it. But any combination of these divided by any combination of those could be a root to the problem. For example, let's say we have this graph here. Looks like that 4 could be a root. Without substituting, how could you determine if 4 is a possible root? First, we would list out, here's our polynomial. We would list out all the factors of -4, which they did here in orange. These are all the possible factors of -4. And then all the possible factors of 8 are here. In order for something to be a rational root, according to the rational root theorem, it has to be a combination of any of these numbers divided by any of these numbers. So they wrote them all out. They started off with the 1s and then the 2s and then the 4s, and in the denominators they had 1, 2, 4, 8, 1, 2, 4, 8, 1, 2, 4, 8. This is a pretty good way of doing it to make sure you list them all out. There's 3 of these and 4 of these, so 3 times 4 is 12, so there should be 12 of these. Some of them are repeated, but that's okay. Positive or -1 over 1 is the same as positive or -2 over 2, which is the same as positive or -4 over 4. But that's okay. List them all out. Now, they asked, is 4 a possible root? Well, yeah, 4, where is it? 4 over 1, right here. So it is a possible root to that polynomial. They miswrote 8 over 2, but 4 over 1 is a possible root. Okay? So for this one, and this one, all you need to do is list the possible rational roots. So you're going to write down all the factors of the of -8 divided by all the factors of 4. Same thing down here with 45 and 7. All right, give those a shot. Come on back when you're ready. I am going to just click to the answers. Hopefully what I showed in the video makes sense. You just listen the factors and dividing them all out. This first one has all of these. And the second one has all of these. You can click pause to see if you got them all. I did not double check to see if there's any errors in their answers. Let's hope there isn't. Your teacher can assign you, I'm in the wrong file, hold on. Here we go. 20, 21, 22, 23, 13, and 16. That's it for this video. Have a great day.